Alright, so this is part 3 of 7 and 8, and the problems in this video I feel are a tiny bit tougher than in the previous two. So don't be discouraged if there's one or two in here that you just didn't know how to do. First one though, we have a triangle XYZ. You're always going to want to start out by drawing your triangle if you're dealing with a situation like that. This angle over here is 64 degrees. We're looking for the sum of angle Y and angle Z, those being these other two angles down here. If you recall from geometry, when you add up the three angles in a triangle, they equal 180. And 180 minus the 64 that we already used, we know we're going to be dealing with 116 more degrees in the other two angles. So that's going to be choice C. Number 2 isn't too bad of a question if you remember the formula that you need. They don't actually give you the formula in the ACT, not always, like they do on the EOC. There's no formula sheets. You have to know some of these more common formulas. We're talking about cylinder, and we want its volume. Formula for volume of a cylinder is V equals pi r squared. That's for the circle on the bottom, times the height, so times h. So the volume that they give us is 40 pi. You plug that in, equals pi times r squared. And they tell you that the height of the can is 10 inches. It's 10 inches tall, so we put a 10 there. I'm going to divide both sides by 10 and by pi to get rid of those. So the pi's will cancel, the 10's will cancel. 40 pi divided by 10 pi is just going to be 4. So I have 4 equals r squared. I end up getting 2 for my radius. That's going to be choice B. Number 3 here is an average problem. Let me see if I can zoom in just a tiny bit here. It's a problem involving finding an average, and it's a very common type of question. Let's see, it's not zooming in. Very common type of question that the ACT does like to ask a lot. So you can typically see at least one of these per test. This guy is a baseball player. He's been playing for 4 years. Here are his home runs per year. He wants to keep his current average number of home runs per season. In order to do that, let's figure out what his current average actually is. To do that, you add up all of your numbers, and you divide by how many numbers you have. You're finding a mean here. When you add up the numbers, it's important that you hit enter. You actually get the total before you divide. So I added them up. I got 164. Now I'm going to divide by 4 and get 41. If you divide all at once, it's not going to give you the right answer. So his average is currently 41. He wants to keep the same average. Okay, this should kind of make sense as a shortcut here. If his average is 41, he wants to stay at 41 after another season. He needs to hit 41 home runs. So that's going to be choice H. If you didn't see that though, or you wanted to do it the other way, he already has 164 home runs. You would do 164 plus something divided by 5 equals, and you would have to figure out 41 times 5, how many points he wants to have. You want his average to be 41. You would do times 5, subtract 164. Just a really complicated way of doing what's immediately kind of obvious. If he's at 41 right now, he needs 41 more to stay there. Question number 4 is a FOIL question. So it's a matter of just doing your multiplication out. 2a times 2a is going to be a 4a squared. 2a times positive 5b squared. 2 times 5 is 10, positive 10, so I put plus 10. And then we have a times b squared, that just stays as is. Then we multiply this guy. You get negative 10, so minus 10, still the same thing, ab squared. And finally, we have minus 5 times 5 is 25, b to the 4th power. B squared times b squared makes b to the 4th. So my minus 10ab's are going to cancel each other. I end up with just 4a squared minus 25b to the 4th power, which it appears is choice A on that one. So moving right along here, on to number 5. We're looking at our question right here, and we have to kind of translate what they say into words. It says the square root of a number n is. Is means equals. So the square root of a number, that's the square root symbol right here, not a squared symbol like these two, those are out. The square root of a number n equals is 19 less than the value of 5 divided by n. So a lot of people will put 19 minus here, but we're going down by 19. That actually has to go on the end. We're tacking on a minus 19 on the end. The value of 5 divided by n would look like this. 5 divided by n, 19 less than that. We're subtracting 19. That's going to end up being choice K. Number 6 here is talking about something called a determinant of a matrix. If you've taken Algebra 2, that should sound kind of familiar, but even if it doesn't, they're nice enough that they tell you what the determinant is. Here's a matrix. We have A, C, B, and D. The determinant is going to be A times D minus B times C. So based on the numbers in the problem, let me see if I can zoom in a little more. It's still a little far out here. Based on the numbers in the problem, you want to just look. It's going to be this times this minus this times this. So in my problem, I have a bunch of w's here. They want you to figure out the value for w. So if you do the determinant, if you do this minus this, you get 25. Now, you could do this problem here using quadratics. You would do this times this. There's a times d. So w times 10 is just 10w minus this times this, w squared equals, we want it to equal 25. And solve this using like quadratic formula or factoring or something. On the ACT, when you're pressed for time as is, honestly, the best approach here is just plug in the numbers, guess and check. This is the values for w. Put it in here and see what ends up happening. So for example, if w was 5, I would end up with 5, 5, 5, 10. If I find my determinant here, I do this times this, so I get 50 minus this times this, that's 25. And that's my answer, actually. I ended up getting lucky. I got it on the first try. So the rest of the answers, you know what? I don't really care about them. On the actual ACT, it might be nice to check them, make sure you didn't mess up somewhere. But that's my answer. Determinant is 25, so it's going to be choice A. All right, I'm going to zoom back out a little bit and talk about number 7 here. This is a pretty challenging problem. This is a pre-calc topic. So if you haven't actually completed pre-calc already, you wouldn't know these vocab words down here going into the problem. They do kind of tell you what's going on here. Like you would have never graphed this in your life. F of x equals 2 times sine of x. That's not terribly important to the problem. But these vocab words here at the bottom are. So they're nice enough that they do define what these things mean. This is the 7th problem on here because it's a really tough problem. Most of you guys on the test would not even want to spend your time on this one. This is a problem you probably want to guess on. But if you're going above and beyond, let me walk you through this right now. So for first one right here, f of x is a one-to-one function. That means that x is unique for all f of x, and f of x is unique for all x. Unique is another way of saying that it doesn't repeat. So if x is unique for all, f of x is really saying y here. X is unique for all y is another way of saying you can't have the same x with 2 different y's. It's another way of saying x can't actually cheat, if you remember function notation. So x can't repeat with 2 different y's. If you look at this graph here, that's basically saying you can't have the same x twice. Anywhere you go, you only use an x once. If there was another point, like right here, for example, if the graph also did like this, that would be bad because this x wouldn't be unique. We used it twice. So this is saying that x is unique. It is. So this part checks out for us. And f of x is unique for all x, means that y is unique as well. So if we find any given y, we can't use it with 2 different x's. That is actually untrue. If you look at like right here, for example, take the y1, we use that y over here as well. The y is 1. So y is not unique. That means that this is not my correct answer. The second choice here says that f of x is undefined at x equals 0. Undefined means that there's no point there. It's not allowed to use. If we look at x equals 0, that's right here. There's a point there. There's nothing like an open circle. There's no asymptote. If you remember that from Algebra 2, if you've taken it, that's clearly not the case. It is defined. There's a point right there. So this is not the answer. That's not true. We have 2 things called even and odd functions. You wouldn't have talked about these yet unless you've been to pre-calc, but again, it kind of explains what it is in the problem. That's why this is a tough one. F of x equals f of negative x. So your y value is the same if you plug in a number or you plug in the opposite of it. X and negative x are opposites. That'd be like plugging in a 3 and a negative 3. And actually, I'm going to use that as my example here. This is saying that if you plug in a number, the answer you get when you plug in the positive version of the number is the same as when you plug in the negative version. If you plug in a positive 3 here, you're going to get out a 2, it would seem. Okay, or pretty close to it. If you plug in a negative 3, so f of 3 equals 2. If you plug in a 3, the y value is a 2. If you plug in a negative 3, you're actually going to get out a negative 2. 2 does not equal negative 2 like this says. This is not an even graph. Next step, we have something called an odd graph. This says that f of negative x equals negative f of x. So if I pick like f of negative 3 right here as my example, f of negative 3, this says it's supposed to equal negative f of 3. Well, f of negative 3 was negative 2 there. That's supposed to equal negative f of 3 was equal to 2. This is actually the answer here. This is an example of something called an odd graph. If you pick a point and you plug it in, like for the x right here, and you follow this rule like I did, it will end up working. Just to show you guys why k isn't the correct answer, it says the domain is entirely within negative 6 to 6. That means negative 6 is over here, 6 is over here. Our graph should only go between these right here. It's very clear though, it keeps on going. So it's going that way, it's going that way. The domain is not just negative 6 to 6. That makes J our correct answer.